Okay, so we've covered while loops, we've covered do while loops, and we've started talking about for loops. So for loops, like we said, are a shorthand for doing a while loop. Essentially, you have three components: the optional initialization, statements that happen before the loop starts. Then you have a test condition, same as in the while or do while loop, that as long as that test condition remains true, you continue repeating the loop. And then some ending statements that normally would get executed at the end of the loop block. So that's the basic structure of a for loop. It's a quick, easy to read shorthand version of a while loop. And the reason why it exists is because many coders find the notation much easier to understand. In particular, these ending statements, you can see what the increments are for the loop, whereas normally maybe you have a long stretch of code for the loop and the top of it is on one screen, the bottom of it is a couple screens down below. It's easier to have all that stuff in one place. Okay. So basic for loop syntax, right? We can do this. We can have, let's see, where's our fun with for loops here? This is what we had. Okay, we basically copied this straight from the slides and pasted it into Eclipse. And when we run it, we have these two separate statements, int x equals 0, y equals 1. And at the end of each loop, we increment each one. Okay, so that's where we left off. If we run this, it goes all the way down to where as long as x is less than 10, it continues. So once x hits 10, that's when it stops. Okay. Now, bit about the syntax. Number one, braces are optional for single statements. So if you only had one statement inside your loop, then you would not need the squiggly brackets. Number two, any variables that declared in the initialization, like right here, even though you would think, well, those statements happen before the loop, as far as Java is concerned, if you declare them this way in a for loop, they only exist within that for loop. And last, any omitted initialization or ending statements, they just get left vacant in the for statement. So for example, I could do a more or less equivalent loop if I wanted to. I could take out this, I could put it ahead of the loop. Okay. I could take out these, and I could put them at the end of the loop. And it's not exactly the same because of the scope of these two variables, but the output is going to be the same. So when I run this, same output. Okay, so again, this part is what looks weird in the for loop, but if you don't have initialization statements or you don't have ending statements, they just look like that. They're just, blank. Okay. Moving on. So incrementing variables is certainly the common way to scroll through a loop, but you can do anything else. It doesn't have to be a variable. It doesn't have to be an increment. So I'll give an example of a very standard one. If we wanted to do this, let's say we have, what do we do? Say we have a new array. Sorry. We're going to make a very simple thing that counts up some numbers, okay? So we'll say string s equals that. Okay, very good, very easy. Now we're going to do a loop that adds a character and then displays the number of characters in the string. So for int L equals 0, L is less than, 13, L plus plus. Okay. Every time through the loop, I can add an extra character. So I could do S plus equals, and we'll do the character, we'll do an L. Really does not want to play along with this. Okay, there we go. Okay, so we'll add an L character to the string. And then we will also system.out. Let's increment L. Let's do it here. I'm going to put the closing statement here. System.out.println S plus S dot length. Okay, so that's what we have. There's apparently something It's a little screwy here. I have a little bit of a problem with this computer. Unfortunately, the mouse, the touchpad, is super sensitive. I do the double tap on it and it clicks things. It's annoying. Okay, so let's run this. Let's see if I didn't mess anything up. Boom, there we go. Okay, so we get our full set of string lengths. Okay, so 1L, 2Ls, 3Ls, 4L, you know, down to 13. That's great. Okay. So at the end of each loop, we increment L and we print out the string itself and then its length. And so in the last iteration, when we come into it, S would be 12. We add an L to it. We do the ending statements. So we increment L to 13. We print out this 413. We do the logical test then. We go back up to the test condition. Is L less than 13? No, L equals 13. So we're done. Okay, so that's it. Now, again, don't have to do this with a single increment. We can do any sort of other operation. For example, I can do S equals plus equals 3Ls as a string. And that's no problem. I'm just going to say L plus equals 3. Okay, so again, first time through L will be 0. Next time through it will be, this is so messed up. I don't know what's happening here with the IDE. Everything is, it's just grabbing text that I'm not really grabbing. All right. Anyway, what's going on here? It starts with L is 0 going in. Each time through it goes to 3. It adds 3 more. So I add 3, then it goes to 6, then it goes to 9. Finally, it goes to 12. Okay. Once S is going to be 12 characters long, I add 3 more L's. I add 3 to it. It's going to print out S, blah, blah, blah. And then the length will be 15. It'll come back and do the test. It'll see that 15 is not less than 13, and it will stop. Let's run it. Okay. Oh, yeah. So here I'm going into that. This is strange. Oh, right, because I didn't update the string. So once again, I was trying to figure out what happened there. It wasn't what I expected to see. So we'll redo that. Boom. Okay, so I have 2 times through it, right? The first time through, it's doing what it did before, went up to 13. Second time through, it's adding 3 L's on each one. So again, those ending statements, they can be whatever. Even though the incrementing is the most common thing, you know, it can be any sort of operation you like. In the case of this example, I'm even including a print statement in the ending. So you can do that. Now, look at this, right? This code we have here, very similar to what we had before. In this one, in the loop, it printed out the string, right? It created the string, then it printed it out, then afterwards it incremented X and Y. So basically the first time through the loop, it printed out the data for X equals 0. In this one, I've switched it around. Within the loop, I increment X and Y, and then as the ending statement, I construct the string and then produce the output. So this first time through, even though X starts at 0, the first thing that happens, this X gets incremented to 1, Y gets incremented to 2, and then as I print out this string, it'll be for X equals 1. So you get a different set of output. The order matters. What happens inside the loop block happens before whatever happens in these ending statements. Okay. So another example of what you might want to do, some use for an array, some use for loops. So loops are very commonly used to initialize arrays. There's lots of other stuff you can do with them, but initializing arrays is a very common thing. But one thing that you might want to do in some sort of text-based application, maybe you would like to count the occurrences of a certain substring within a larger string, right? So imagine you have a large slug of text and you're looking for matches within that text, or you have a database full of items and you want to find all the records that match some particular query specifications. Okay, so for whatever reason, you want to find matches in a giant slug of text. So you might do something like this with your loop. So you might say, read a string from your GUI graphical user interface, right? Whatever window the user has open. So read some text string from the user interface. The user enters some specified substring, whatever they're looking for, and then you have a count variable to track the number of occurrences of that text you find. So you start at index 0 and you continue until as long as there's room to find this substring. So however long substring is, if some substring were 1 character long, you could look at the very last character of the string, and then that would be fine. You could find the match there. If it were 2 characters long, you'd have to you would stop looking at the next to last character of the string, and so on. So as long as x is less than text length minus sub.length, length, right? So the length of the string, right? The length of this big string minus however long the substring is, you can keep going. There's still room for it. And you can see that very easily. If the substring's length is 1, then as long as x is the last index of text, right? Text.length minus 1, then you know there's still room to check. Okay. Anyway, so going on should be, I suppose, should be less than or equal. Well, yeah, it should be less than or equal to. That's all right. We can even make that edit here. Okay. Then all you're doing is you're trying to find if that substring in text matches whatever point you're looking at in the big string of text. If it does, you increment your count, right? So you say if sub.equals, if this text string substring, right, if it equals sub itself, right, the substring we're looking for, then you found a match and you increment your count. At the end, after you've gone through this whole loop, so this is, even though it's a long statement, it is a single statement, so we don't need the squiggly brackets. So once you've gone through the entire loop and found all the matches, then you can print the number of matches that you find. Okay, so let's go ahead, let's paste this into our thing here. We can do something like this. We'll call it find matches. Let's say match finder. That's catchier. Okay. And we're just going to paste this right in. Boom. So let's say, what is our big text string going to be? It'll be the quick brown fox jumped over the lazy dog. Okay. Very common typing sentence. And let's say our substring is the. Okay. We can look at this text and say, oh yeah, there's 2 thes there, right? The and the, fine. So in count equals 0, let's see what went wrong here. Sub dot equals text dot substring. Do I need an extra parenthesis? I think I do. Yeah, maybe 2 more. Yeah, okay. So what I'm doing here, right? This is a string. Yeah, text.substring. So it's starting at x, starting at the index we're looking at, and continuing for sublength characters. Okay, so remember the number of characters in a substring is the second number minus the first number. So this is the length of the string I'm checking. I want to see if it has the same text. Okay, if it does, then I increment count. So let's go see if we run through this. I could see okay, and it should be 2 as long as everything's working correctly. There we go. 2 matches found for the. Great. If I want to do a different word, if I want to do, say, quick. Okay. 1 match found for quick. Yeah, 1 matches. All right. Let's do this. All right, hold on. I got to pause this for a second. I have a fairly urgent call about a... Okay, we're back on. So that was a car, call about a car, getting a new car, and I got to put it on the insurance. So that's exciting. Anyway, so this is something you can do with loops that doesn't really require an array. We'll get to arrays next week. Wonderful. Okay. And let's fix that. I think I need a couple more. I'm gonna stretch you out. You get your 2 more parentheses there. Okay, it's a lot of parentheses. Okay, so that's it. That's it for loops. You know about loops now. Hooray. So there's a few things to remember. Number one, after the loop, if you have a conditional test variable, it's going to have the first value where the test is false. So look at this example here. We start off with x is 2. In our loop, we continue as long as x is less than 256. Okay? If we print out stuff after the loop, what's going to happen? Well, let's see. I can just paste all this in. Do more fun with for loops here. Okay, so this last one, we're going to run this. And after the loop, it's going to say 256. Okay, boom, 256. Reason is 256 is the first value where this condition will be false. So we start off with 2. Each time through the loop, we double it. So 2 goes to 4, 4 goes to 8, 8 goes to 16, 16 goes to 32, 32 goes to 64, 64 goes to 128, and 128 doubles to 256. So in this part, right, once x is 128, this part is still true. That's how we got into the loop. We double it to 256. We do the test. The test is false, so we're out. So when we reach this statement after the loop, x is going to be 256. So always remember, this test variable, it's not going to be the last value where that is true. It's going to be the first value where it's false. Okay, very common error that can happen. Number 2, in general, unless you deliberately plan on doing an infinite loop, in general, a loop should progress toward completion with every iteration. So every time through the loop, it should get a little bit closer to being done. That's a good reason to do increment and decrements, right? You have a target value, and every time you go through the loop, you get closer to that target value that'll end the loop. Inequality tests in particular are dangerous, because if you're not fully understanding how your loop is structured, it's very easy to go zipping past that inequality accidentally, and then you're stuck in an infinite loop that you didn't really mean to happen, or a nearly infinite loop anyway. So various wrong things could happen. Number 1, could cause an overflow, or number 2, could stick the program in an infinite loop. So I'm going to set up a new thing. I'm going to set up a new class in Java. It's going to be with some of these trouble with loops. Okay, we'll make a new one. Okay, so let's make a few methods here. So static void loop 1. Okay, in loop 1, here's what we have here. Say demonstrates troubles with using equality tests on floating point numbers. Okay, so here we start off with int x equals 0. We continue as long as x is less than 10. And each time through, we multiply x by 1. Okay, well, that's obvious that that's going to be a problem, because x is just going to be 0 forever, right? So if we run this one, we're just going to get stuck in that infinite loop. Oh, we're not calling it. I got to call the loop. Okay, let's do that. We're just stuck in 0 forever, right? So that's silly. That shouldn't happen, but sometimes it does. So let's get rid of that. That one's too silly. But this one, we start off our z with 0. Okay, so 0.0, floating point number. We continue as long as z does not equal 10. Each time through, we add what we think is going to be 1/7. Okay, but what's the problem with this? Well, the problem essentially is rounding errors, as you will quickly see. So the problem was, very quickly, we just missed that equals 10.0 by some tiny little amount like this, by some, 1 millionth or 1 billionth, something like that. And that rounding error meant that we didn't hit this inequality. So even though it looks like, oh, we're adding 1/7 each time through. No, you're not. You're adding some decimal number that's pretty close to 1/7. So if we do this, if we say continue as long as it's less than or equal to 10, you'll see what happens, right? We're not going to hit 10 exactly. So this first time through, right, this 1, we get real close to 1, but it's not 1. It's 0.9 and lots of 9s and an 8. Okay, we go through here. Here we go. 2 and a whole lot of 9s, but it's not 3. Okay, here we get 5 and a whole lot of 0s and a 1. See, when we finally get to 10, right, so 10, yeah, as long as it was less than or equal to, this one actually worked out okay. I wasn't sure how it would tip because you can see it's a little bit unpredictable, right? Some of these early ones, they're just under the number. Some of these other, right, here's this one is just under 2. This one is just under 4. But as it happened, and this one is just over 7, you never know exactly how it's going to shake out with these. Floating points are pretty unpredictable that way. But this time, yeah, it actually worked. But we had to take our chances with it. And this sort of thing can actually make debugging really difficult because sometimes your code might work great, and then every now and then, for reasons you don't fully understand, you'll get something like, oh, it rounded up instead of rounding down, and then this loop doesn't work. So that's a frustrating thing. Okay. So for that, you should avoid conditional testing, especially inequality testing with these floating point types. Okay, so for example, we got another one here. I'm going to copy this into loop 2. Make a new method here. Okay, so in this one, we're just going to call loop 2. In this one, we have a float variable. Remember, float is the shorter of the 2 floating point numbers. It's a 32-bit floating point number. We're going to continue as long as x is less than 103. And each time through, we're going to add 2 divided by 3. Well, let's see what happens. So we would think we start off at 1. Each time through, we're adding 2/3. Eventually, we should hit 103 exactly. Trust me on this. But you'll see, because of the, again, the number inaccuracies, rounding errors, it's going to be a little weird because floating points only go to like 7 or 8 decimal places, depending on what's going on. So when we hit this one, right, as long as x is less than 103, sure, we continue, okay? But at the end, it works out like this. So using an inequality is pretty safe, okay, except for when it isn't. But this one worked out all right. But it's much better to do a margin of error, okay? So what we want to do, really what you want to do is something, you know that it's going to be close to the target variable, but it's not going to be exactly there. Instead, it's better to do something like this, right? So as long as x is greater than 100, you know, between, as long as it's really close, not really close to this, we're going to keep on going. Okay, so in this one, if we did less than or equal, for example, to 103, again, same trouble with rounding errors. Okay, it's not going to hit 103 exactly. So I'm going to run this one through once more. Okay. So at this one, yeah, it should have continued, right? Should have hit 103 exactly. It didn't. What happens after loop? It's okay. What if we try to do it as a smaller number, right? What if I try to do it at, I don't know, let's say 13. Let's see. All right. Let's try to do it at 1,003. I'm just trying out some different things to see if it ever, this one seems to be doing well today. All right. So rounding errors, again, sometimes it can work, sometimes it doesn't. This time we're okay with this one. All right. But this one here, each time through, I add 2/3. But the better approach is to do this, is to just check to see if you're close to the number. Okay. I mean, if I wanted to do this one, I could do the exact same thing here. I could say, yeah, as long as z is less than 9, right? I mean, heck, if I did it with 2, then what would happen there? Oh, I wanted to do loop 1. Sorry. So in this one, right, if I picked a different number here, when I picked 10, it didn't work, right? I said z is less than 2.0. The loop actually stops before that, okay? Because this next number that I pick is going to be one that's over it. So what should be, I should print out, it should print out the next one. Like if I do with 10, 10.0, all right, let me do that. System.out.print.z, well, that's the last one. Okay. All right, strange stuff with floating point numbers. Okay. But anyway, better to include a margin of error like this. Last one, overflows. Okay, so this is something where it requires a little bit of knowledge about how the numbers are structured in Java. So for integer types, remember, integer types are stored as exact numbers in however many bits they require. But what happens is the exact number is always retained. It's just that anything above the highest bit gets discarded. So we don't really need these multiple things here. I'm just gonna dispose of these. What I'll do, okay, so if I start off with a number, let's say int x equals 1. Okay, and I'm going to do a for loop. For int nothing, x is less than, we're going to do it as long as x does not equal 0. Okay, and each time through, we're going to multiply x by 2. Well, the strange thing is, this loop will actually end. Eventually, we'll hit 0 by multiplying x by 1. Okay? So we're going to keep track of another number. We're going to call it power x. Log base 2 of x. Log 2x equals what? Is going to also equal 0. Okay, so each time through, we're going to increment log 2x. Log 2x plus plus. Okay, so you're with me? Good. So each time through, we're going to say system.out.println x plus log base 2 of x equals plus log 2 of x. Okay? Let's make those lowercase. Okay, so each time through, we're going to do that. Eventually, we're going to hit 0, and we're going to see some really weird stuff going on here. Okay, let's do it. Oops, got to call loop 2. Okay, so we start off, x is 1, so good. Log base 2 of x is, it should be 0. Should do that first. We'll do it again. Okay, now we're going to do it. So initially, x is 1, log base 2 is 1, right? Each time we're adding an extra power of x. As we multiply through, the numbers keep getting bigger. Well, when we hit 2 to the 30th, that basically means our binary code looks like 0, 1, 0, 0, 0, 0, 0, 0, and then plus 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Our binary number looks like this. When we this is x equals 2 to the 30th. When we multiply it again by 2, we get, and then the rest of this all remains the same. Okay, so that's 2 to the 31st. So times 2 equals, okay? But Java recognizes this as a negative number, right? Because this highest bit over here, this highest bit is a 1. That's the flag that Java uses to determine whether the rest of the number is negative or not. So instead of having, 2 to the 31st, some number around a couple billion, instead we have a number around a couple negative a couple billion. And when we add one more to it. When we multiply it through by 2 again, what happens? What happens is this all just goes to 0. Okay? This is how Java recognizes 2 to the 32nd when I multiply it out. It says, oh, that's 0. So again, if you're doing stuff with these big integers, you may find that negative 2 billion times 2 equals 0. This is an overflow problem if you're not aware of it. Okay. Other things like floating point types, any number that gets really large will eventually be given the value plus or minus infinity. Okay, so if we do this, for example, we have some absurdly large number. I'll do this one as loop 3. So static void loop 3. Okay. Okay, so here I'll say trouble with integer overflows. Okay. I guess here at the end I'll just do okay. So this one I'm going to do an absurdly large number. Okay, so for int 10 equals 0, 10, I don't know, let's do value equals 1.0. 0, value, I don't know, do while it's greater than 0. Do while, no, let's just do iterations. So int its equals 0. Okay, so int val equals 1. Not val, double val equals 1.0. Do while its is less than, I don't know, 340. Sure, we'll go with that. And then val times equals 10.0, whatever. Okay, so each time through this loop, we're going to multiply value by 10. So we're going to print it out, system.out.println val. Okay, easy. We do its, I guess its plus val. Okay. So let's see what happens. And we got to increment its once. Let's do it here. Okay, we'll run this. We have loop 3, good. Okay, so initially to the 0 times 1 times 10 to the 0 is 1, 1 times 10 to the first is 1.0, 10 to the second is 2. Go on, go on, go on. And you can see even here we start to see some crazy rounding errors, right? So if you're looking for an exact number match, you could be off here, right? So this one is exact, this is not. Okay, eventually we don't see many of those inexact ones. Okay, but here again, oh, look, here's one. It went to, there's a 1 there. Here's some weird 3s and 4s. But once we hit that big number, once we cross that 308th, boom, then we enter the realm of infinity. Number so absurdly big that as far as Java is concerned, this is a super big number. It is infinite. And once a double becomes infinite, you can't do anything with it. It's still infinity. So for example, right, at the end here, let's go back to Eclipse. At the end, here's infinity. Val is a very large number. Okay, so I'm going to say double val equals 1.0. Here, this way I just have it here. If at the end I want to say val equals val divided by, let's say val itself, infinity divided by infinity, let's see what happens. Oh, did I not print it out? Oh. Okay, we'll run that again. And the final value, NaN, for not a number. So once you try doing some infinity math, bad things can happen, right? You can't really, there's not a way to get out of that infinity state. Okay, so that's some problems that can happen, overflows with doubles. So the point is, they behave differently. If you're dealing with an integer and it gets absurdly large, it can flip around, become negative, become zero, get some unpredictable positive value. If you're dealing with an absurdly large floating point number, eventually Java says, nope, this is infinite, and we're not even going to play around with it anymore. It's just, it's gone off the rails. It's too big to handle. Okay. So that's it. That's stuff, and again, that's stuff to watch for with loops. This sort of thing does happen. If your loop is not properly regulated, then if you just let something keep on increasing forever, you may find one of those things happens. Okay, questions about any of that? What do we got here? What's going on? We have something in chat. Okay. What kind of car? Oh, it's an old Mercedes. It's just a little sports car. It's nothing too fancy. We're my parents are actually getting rid of it and they're giving it to us, so we'll take it. It's nice. Yep. So anyway, that's what I got. Any questions on any of this array stuff? Does it make sense? You guys think you can do loops in your own coding? I hope you can. Maybe let's go to a coding bat. Let's do one coding bat. We got a few minutes left. We'll do a coding bat. Okay, let's see what we get here. All right, I'm going to let people, you can pick one. We'll do another array problem. Basic array problems, no loops. Oh, wait, no, we do need loops. Medium string problems, one loop. Sounds good. All right, let's see what we got. Simple one. Anybody want to call one out? Oh, here we go. What we got? Count high. All right. So boom, return the number of times that the string high appears anywhere in the given string. Oh, that's fun. This is exactly the same thing that we did in my text analysis code just a minute ago. So I could practically lift that code and paste it right in, but let's go ahead and do it from scratch. So for index equals 0, index is less than or equal to what? str minus length, str.length minus 2. Yeah, because I need 2 characters there. If I'm starting at, yeah, then that's fine. And then index plus plus. Okay. I'm just thinking out loud there. Now, if I do this count high, ABC high, 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 ho, okay, I need a count to keep track of how many there are. So int count equals 0. At the end, I'm going to return count. And so here I do the substring match. If high, if that literal string equals what? The substring starting str.substring starting at index and going to index plus 2. Yeah. Then what? I need an extra thing there. Then count plus plus. Okay. I think that's correct. Let's just think if it were 1, I'd want to do less than or equal to string.length minus 1. That seems fine. Let's see what happens. Oh no. Oh, I didn't int. I didn't declare it. And I got this insert button on. Okay, now let's try. Yay, all correct. Okay, good. So this is the same problem that I did before, right? That I included as an example in the slides. Well, I'll walk through it again quickly because we have a minute. So first, we want to have a count variable that records how many times we find high in the string. And initially, we're going to assume that we find 0 because we haven't found any yet. At the end, we're going to return however many we find. So this part, we do a loop through it, okay? We start at index 0, and we continue as long as there's room to find the string hi. Well, if I'm starting at string.length minus 2, that length minus 2 could be the h, length minus 1 could be the I. There's enough room for it, and it ends the string. So I know that's the last place I have to look. So as long as index is less than or equal to str.length minus 2, I know that's something I have to check. If it's not true anymore, then I'm done. And at the end of each loop, I just look again, starting at the next index. So if I find hi, if I find a match, so if this literal string hi equals the substring, and remember the dot equals method just means it has the same text, doesn't mean it's the same object. So the substring here, starting at the index of str, the index, and continuing through to index plus 2, all right, if those two characters match hi, then I increment the count, right? Another way to do this could have been if str.char at index equals h, and what's the other one? Str.char at index plus 1 equals I, then count gets incremented, right? That's another way I could have done this. So let's see. I can comment that out. I can uncomment this, go again. Shit, I missed a parenthesis somewhere. Right here, probably. Oh, right here? Yeah, right here. Okay. And you can do it that way too, right? You can just as well do it with 2 characters as you can looking for a 2-character substring. Although if, you know, it's a long substring, then you don't want to do all those individual characters. But for 2, it's not a problem. Okay, questions on that? Questions on anything else about strings, about arrays, about loops? Well, not arrays, because we're going to cover that, but okay. So remember, for those of you who joined late, I'm putting this in chat right now. Friday will be an unusual session. So no real lecture, no slides, but what I'll do, I'll cover Eclipse's debugger, which is useful sometimes, okay? And I'll talk about debugging generally. Things like where to put diagnostic code, right, to see what your program is doing. Many coders prefer to insert little output statements somewhere, depending on the application you're doing, either to the console or somewhere else, indicating the state of the program. The debugger works, but for a complex program, it's really slow and tedious to go through. Okay, so I'll talk about that, and then with any extra time, and there should be plenty, with extra time, I can answer questions about coding and such. Okay, whatever stuff you got. So that's the plan for Friday. No formal lecture. If you want to tune in, learn a little bit about debugging, some stuff that might make your future coding a little easier, yeah, I'll be talking about that. Okay, so that's all I got for today. I didn't know I was still recording, but I guess I was. Okay, stopping recording.